welcome to the Explainer. Today, we're going to talk about something kind of wild. An AI that doesn't just, generate an image. It actually writes it, piece by piece, almost like it's telling a story with pixels. And believe it or not, this one little shift in how we think about it, it could change, well, pretty much everything about how AI creates pictures. Okay, so let's really dive into that question. Imagine for a second, instead of an AI just, poof, creating a whole picture at once, what if it built it up sequentially, one little bit at a time? Well, that's the whole idea behind this new model called Next Step 1. And what's so interesting is that it really goes against the grain, against some of the biggest trends we're seeing in AI image generation right now.
So to really get why this is such a big deal, we kind of have to back up a little. We need to talk about the central problem that AI image creators have been wrestling with for years now.
For a long time, the whole field has been dominated by two main approaches, right? On one hand, you've got these super powerful diffusion models. They create absolutely stunning, high-quality images, but they're also incredibly complex and just computationally heavy, a real beast to run. And then on the other hand, you've got autoregressive models. Now, these are the same kind of models that power language AIs like GPT. They're way simpler, kind of more elegant in a way. But for images, they've always had this problem. They've struggled with quality, losing a lot of important detail. So you are always stuck with this trade-off. Do you want quality or do you want simplicity? You couldn't really have both.
But what if you didn't have to choose? That's the powerful question the researchers behind Next Step 1 asked. What if you could actually get the best of both worlds?
And their solution was just so clever. They decided to treat making an image exactly like generating language. Think about it. A language model looks at a sentence and predicts the next word, right? Well, Next Step 1 does basically the same thing. But instead of predicting the next word, it predicts the next little patch of the image based on all the patches it's already put down. It is literally writing the image one piece at a time.
So, okay, how does this actually work in practice? Well, first, you've got this massive 14 billion parameter transformer. That's the model's brain. And it reads your text prompt to figure out what you want. Then, based on that, it predicts what the very next little square of the image should look like. After that, a smaller, really efficient component kicks in and actually generates that one patch. And then it just does it again and again and again. Patch by patch, row by row, until the whole picture is finished. It's a really elegant idea, but there was a huge technical challenge hiding in there that almost broke the entire process.
Now, you'd think that the giant transformer brain is the star of the show, right? It's the biggest part. But as the team started digging deeper, they found something really surprising. The real hero, the key that unlocked this whole thing, wasn't the brain at all. It was a much smaller, kind of overlooked component.
Okay, so to get what they discovered, we need to talk about this one thing called Classifier-Free guidance. You can just call it CFG. The easiest way to think about it is like a knob you can turn. If you turn the knob way down, you're giving the AI a lot of creative freedom. You're basically saying, hey, draw me a cat, and letting it figure out the details. But if you crank that knob all the way up, you're forcing it to be super literal, super strict. You're saying, draw me a photorealistic orange tabby cat, and it has to be sleeping on a blue pillow. You're giving it very specific instructions.
And here's where the mystery comes in. With older models that tried this kind of approach, cranking that CFG knob up too high was, it was a total disaster. Forcing the model to follow the prompt too closely made the whole process just fall apart. You get these bizarre artifacts, random noise, sometimes just big gray patches that completely ruin the image. It just didn't work.
So, the team's big breakthrough was completely counterintuitive. It's one of those things that sounds wrong, but it works. They figured out that if they intentionally added a specific kind of randomness, a bit of noise, while they were training their image tokenizer, that's the part that breaks the image up into patches, the model actually did worse on its training tests. On paper, it looked like a failure. But, and this is the crazy part, the final images it made were suddenly dramatically better.
And this chart right here shows you the problem perfectly. This is what happens without their fix. When you crank up that CFG, just look at it. Each bar here is a new patch being generated, and you can see as the process goes on, the values just go haywire. They skyrocket. It's total statistical chaos, and that is what was creating all those ugly, weird artifacts in the final picture.
Okay, now look at the result with their fix. It's like night and day, isn't it? By adding that bit of noise during training, their tokenizer learned how to normalize the data for every single patch it made. See how the bars are just perfectly flat and stable now? The whole generation process is completely under control, even when you crank the guidance way, way up. They basically tamed the chaos by controlling each tiny step of the process.
So, okay, that's a really clever fix for a super deep technical problem. But what does it all actually mean for you, for me, for the future of making images with AI? Let's talk about the promise and the limitations.
And the promise here is, honestly, it's huge. Because Next Step 1 is built on a language model at its core, it just gets text in a much deeper, more nuanced way. What does that mean for you? It means it's fantastic at creating really complex scenes, with multiple subjects that are all interacting in the right way. So the big takeaway here is that models using this kind of approach, they can become the go-to tool for those complex, story-driven images that the big diffusion models sometimes kind of fumble.
And this isn't just a cool idea in theory. The results really back it up. When you put it to the test on these really tough advanced benchmarks, the ones that check how well a model can handle really complex prompts, Next Step 1 is performing right up there with the big guys, like Stable Diffusion 3.5. And that is a very big deal. It's proof that this simpler writing approach can finally compete on pure image quality.
But of course, it's not perfect. Not yet. Because it's generating that image one tiny piece at a time, it's just slower right now. Remember that analogy of writing a novel one letter at a time versus just printing the whole page at once? That's kind of what we're talking about. It can also create its own unique kinds of weird artifacts, like these faint little grid patterns. So here's the practical takeaway for you. If you need a result and you need it fast, this method probably isn't the one for you today. Speed is still the price you pay for its incredible compositional smarts.
So what's the big takeaway from all this? Well, Next Step 1 is basically proven that these autoregressive models, the ones that write things, are now serious contenders in the world of image generation. And it's all thanks to one really clever, counterintuitive insight about how to train them. By teaching an AI to write an image, these researchers have opened up a completely new path for development. And that leaves us with one final, pretty fascinating question to think about. If an AI can learn to write an image, what could it learn to write next? I'd love to hear your thoughts on that in the comments.